Hello everyone, this is the first lesson recording for IM2 October 5th, 2020. So we started off with a quiz number 3, transformation and triangle congruence. It was 12 minutes, and if you were absent for this quiz, you need to contact me as soon as possible to arrange a time to make up the quiz. Goal for the day, we are going to experiment with dilations on coordinate plane. To begin, we are going to look at pantograph. So it's a device used to make exact enlargement. I'm going to watch a short video. Okay, so that's how pantograph was used to enlarge or reduce images. And if you were in person, you will be creating your own pantograph using some rubber bands, but we are not going to be able to do that. But we are going to do next best thing, which is Desmos. So please log in to the Desmos link that's going to be on the slides. And you're going to go on to card number 1, 2, 3. Okay, I'm going to assume that you've had a go and just going to quickly go through. So this is where you are just creating your own pantograph. So if I was to draw an image like, say, a heart looking like this, you see what I drew in this dark red, okay? And then an image is created that was enlarged. Okay, if I try another machine, different machine, what this one does is it creates an image that is just slightly bigger, not like the previous one. Okay, the previous one was much bigger, maybe like 2 or 3 times bigger, and this one is just slightly bigger, maybe twice as big. What about this? Okay, I am creating my image here. But the enlarged or the image that I've created is actually smaller, so we call this reduction. And then finally another image. Okay, and look what happened. Okay, so we have 2 images on either side. This one doesn't show so well, but if I was to show, okay, if I was to draw a figure that looks more like a D, the image is actually rotated here as well as reduced. Okay, let's go to the next card. Now here, this one asks you to trace this. Okay, so if your pantograph is right here and you're tracing it along here, and look, you're just using it just like the pantograph. You're following the image that you want to copy, and the pantograph created this triangle. I didn't do a very good job, but that's basically the idea of a pantograph. And you can set the enlargement to be different. Okay, so then it asks you, a dilation is a new type of transformation that you have been exploring in this activity, so move point A. So I can move this point A. Look what happens. Okay, does moving point A change the size of the image? The image that I created here, is that getting bigger or smaller as I move this about? No, it's not getting smaller or bigger. However, it's getting closer to the original triangle or farther away. So the location is changing, but the size is not. So location is changing, but the size is not. And you can put in your explanation there. Okay, now, so if I was to dilate this small heart and created this bigger heart, that's a dilation. If I put this in the coordinate plane, how does a coordinate plane help me specify the dilation exactly? Well, there are 2 degrees of freedom. That means there are 2 different things that's going to determine the dilation. The first is the scale factor, and the second is the center of dilation. Okay, so now you're going to go on to card number 4 to 8, and where the scale factor is fixed, and you're going to change the center of dilation, and you're going to be using the projection lines. So let's quickly summarize what you should have noticed, observed from card number 4 to 8. So when you move the center of dilation, the image does not change in size, right? But the position changes. And if we were to use the projection lines, what is a projection line? Projection lines are created by connecting the corresponding vertex of the image and pre-image. So if I was to say this is the pre-image, this vertex corresponds with this vertex. So if I was to draw a line between those and extend it further, we call this the projection line. And we can do the same for all the other corresponding points. I know that this point vertex corresponds to this vertex in the image, and likewise I know that this vertex in the pre-image corresponds with this point, and then lastly there are many more, right? This vertex corresponds with this. If I was to extend each of these lines, what happens is that they all meet, they all intersect at the point of dilation. Okay, so when you join the corresponding points or vertex of the pre-image to image and extend that line, they will all meet at the center of dilation. So please pause the video and take notes on this. Then you are to go on to card number 9 to 12, where this time point of dilation is fixed, but you are looking for change in the scale factor. That's the first 2 cards, and then last 2 of these is where you are changing both. Okay, this is time for you to explore, so please go ahead and do so. Okay, I'm going to assume that you've had the chance to explore, and I am going to summarize what you should have noticed from there. Okay, so if you have a scale factor of 3, this is the pre-image, and the red is the image. This is what you're starting off with, the original, and the after dilation, this is the final image. Okay, and it had the scale factor of 3. What does that mean? That means look at all the side length. So this was 1, 2, 3 units. This side corresponds to this left side on the red image, and there were, if I counted this, there were 9. Okay, and if I was to look at this base, there was 2 here and then 6 units across here. Okay, and if I was to do all the sides corresponding, this was 1 unit here, 3 unit here, 2 unit, 6 unit, 1 unit, 3 unit. can tell that the corresponding side length is increased by the scale factor. So there were 3 units. 3 times 3 is going to be 9. 1 times 3 is going to be 3. 2 times 3 is going to be 6. Okay, so on. The side length got increased by the scale factor. Okay, what about the position? Okay, what about the position? If I was to consider this point here, okay, I know that from the center of origin it went 1 unit to the right, then 1 unit up. So 1 unit to the right multiplied by 3 will be 3 units to the right. So that's going to be, instead of 1 unit, it's going to be 3 units to the right. So I am going to do 1, 2, 3 units to the right, and instead of going up by 1, I am going to go up by 1, 2, 3. 1 times 3 is going to be 3, and this is the corresponding point to this. Okay, and likewise I can do the same thing with, let's pick another point. Okay, well, if I was to pick this point here and this point here, they are corresponding. How did they come about? Well, I know that it's 3 units to the right, 1, 2, 3 units to the right, so plus 1 unit up. So instead of going 3 units to the right, I am going to multiply 3 by 3, so that's going to be 9 units to the right. That's going to be right here. And instead of going just up by 1, I am going to go up by 1, 2, 3, and that's how you get that point. Okay, how would you get, let's call this point. Okay, how would you get this point? Okay, so I know that to get to that point, I moved 2 to the right, and then 1, 2, 3, 4 up. So instead of going 2 to the right from the center, I am going to go 2 times 3, which is 6. So I'm going to go 1, 2, 3, 4, 5, 6 to the right. And instead of going 4 up, I am going to multiply 4 by 3 to get 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and which lands me right there. So that's how you find the corresponding vertex on the coordinate plane. Finally, putting it all together, you're going to go on to card number 13 to 18. Once you're done with all the way to 18, then you're going to go all the way to the end. Okay, please pause the video and complete the Desmos exercises. Alright, so this is what you should have been doing. So if you have a scale factor of 3, you are supposed to create an image with a scale factor of 3. How would I do that? Well, I am going to use the same method that I did to figure out the vertex. Okay, so to find the corresponding vertex to this point, I know that from the center it moved 2 to the right and 1 down. So with a scale factor of 3, instead of moving 2 to the right, I am going to move 2 times 3, which is 6. 1, 2, 3, 4, 5, 6. And then instead of going down by 1, I am going to go down by 3. So this point corresponds to this point. Okay, this is my new point. And let's do another color for a different vertex. Okay, so if I was to look for a vertex that corresponds to this, I know that it 1, 2, 3, 4, 5 to the right. There is no vertical change, so instead of going 5 to the right, 5 times 3 is 15. So I'm going to go 15 to the right. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's right here. Okay. Okay, so I've gone ahead and found my points. So I have one point right here. Oh no, I'm sorry. I have my point right here that corresponds to this. I have my point right here that corresponds to this point. And I have this point corresponding over here, and then this point corresponding over there. And when I join the vertices, this is what the image should look like. Okay, I'm going to continue with my next lesson recording.